But now let's take a step back. We've looked at historical data to predict likelihood. One, we understand that the underlying model is wrong. We understand that the underlying model does not cater to seasonality, does not cater to the fact that this is all a pre-pandemic data set, that does not include the impact of what's likely to happen in 2020. All of that is right? But what are we doing? We've just done a dry run. We've just done a simple, short, basic exercise to get a sense of what's the likelihood. And the key point to remember is not that, so these numbers that we've generated, right? These numbers are not as important as the actual journey of getting to them, to go through the results, to get a sense. Now, to be fair, what you really wanted to do is, ideally, if you had enough data, historical data, what you would do is you would make some adjustments. And you would make those adjustments based on the seasonal impact. So for example, one possible adjustment that you could do is you could just look at Q1 sales. These are your Q1 orders. These are your Q2, Q3, and Q4 orders, the rest of the year orders, right? So this is Q1, this is rest of the year. You could factor in the fact that if I have Q1 figures for 2020, because I already have numbers for Jan and Feb, and I have a forecast for March. So if I have a forecast for March, if I take my Jan, Feb, and March figures, if I take these three figures, I can actually build a forecast for 2020. That's one possibility. A second possibility is you could actually do month by month. So there's lots of tweaks, lots of adjustments that you could do, right? Second possibility is you could actually take a look at what your outlook for 2020 is, and then think in terms of what March would look like. So there are lots of things that you could possibly do in terms of improving, in terms of refining your model. Some of that stuff we've done here, right? So for example, growth, if you just look at the 2-year average for which is 2018-19 for your orders, your 2-year average says your March number is likely to be about 940 if the world was normal. Your 2-year average says this number, right? This growth. What does this growth represent? This growth represents year-on-year growth. Your 2-year average data indicates that March numbers over prior year are likely to be about 30% higher based on 2018-2019 data. So you have that information. You also have the impact of seasonality. So March is the start of your season. That's when sales start to step up. That's when sales start to kick up, right? So your expectation is that given the fact that there's only growth, it's a seasonal month, it's an important seasonal month, the non-pandemic business as usual scenario would say March going to be higher. However, you can clearly see that things are slowing down. People are concerned. Lots of issues or concerns or reservations with respect to spending, with respect to inventory, with respect to supply chain. So there are other factors that will come into play. But for our purposes, despite all of these considerations, this is a first pass of our model. This data that you see in front of you, right? What's your take? Do you think 2020 is going to be a good year? Do you think 2020 is going to be a negative year? Do you think 2020 is going to be an okay year? Do you think 2020 is going to be a growth year for Maya? So if you now look at the numbers, this was the actual March figure. The actual March figure, month on month basis, was down. So in percentage terms, you were down by one minus. You were down by about 38%. So this is March, right? But then April picked up, and April they stopped. So if you think in terms of okay, so this should be this by this minus 1, and let me just put this out, be this by this minus 1. So that'll fix it. So that's about. So now if you look at growth trends for Maya in 2020, you find that March was down, April was up just by a notch, May was down in a major way, and then June, July, August, September, October were big months for them, as in they were record-breaking months for them. And year on year total, right? So if you think in terms of the total number of orders, so this is 2020 and this is 2021. So they grew. They had about 11,000 orders in 2019. They had about 12,600 orders in 2020. And I think so far for the year, I think May is about 1,100 orders. That's the latest number. That's where Maya is right now. All right, so quick exercise. So you have these numbers now in front of you. You've seen the model. You looked at the figures. We've used multiple approaches. You have these figures for 4914 for the year. You have this figure for 12597 for the full year last year. You have this figure of 10956 for 2019. What do you think 2021 is going to be like for Maya? If they've done 5,000 orders, roughly 5,000 orders for the year, what's the easiest way of answering the full year outlook question? How would you do that? So, vaccines are around. There's a lot of optimism. Travel is opening up. Logistics are getting better. China's recovering. US, Europe are both picking up. So things are beginning to finally look better, right? We also expect certainly hope that schools will reopen. We've survived the third wave, alhamdulillah. And things are looking slightly better, much better than they were in 2020, but slightly better in 2021. Give me a number for Maya's total orders for 2021. All right, so let me see. Sales up to May. Sales for the, not sales, orders. Orders up to May. Orders for the full year. Projection. Okay, factor. Let's just take a factor. So if I do this, I'll just do a simple calculation. Sum this, which is sales up to May, and then sum this, which is sales for the full year. And my factor would then be this divided by this. And then I just extend this across the board. There you go. So that's my model. So my model says if I look at the last 2 years, your relationships between 2.5, 2.2 and 2.9, if I pick this as, if I take the last year, then my number is going to be this times this, which is 14,483. Then it's 14,483. If I use if I use 2.24, if I use this one, it's 10,996, which is 2019. If I use 2018, it's about 12,213, right? So I've got a range. I've got maybe 10,996, which is the 2019 figure, I've got 14,400, which is the 2021 figure based on the 2020 model, and I've got maybe 12,500, which is the third model. So again, as I said, there are no right or wrong answers. We just figuring it out. We just coming up with the model. The idea on our part, on each individual's part, is to run through the model so that they're familiar and comfortable with how and where the numbers are coming from and how does the underlying business work. And you're free to change your outlook, your figure, your answers, your numbers as more data. Wait for more data. And I think one of the big challenges for us as founders is that a lot of times you don't have time to wait for more data. We actually have to make a call. In Maya's case, the call is we're sitting in February. The window for placing an order, shipping it from China, Vietnam, Thailand, and getting it into Karachi, into their warehouse, is closing. So they can, if they wait, that window will close and they'll be stuck without inventory. They have to order. Question is, how much do we order? Do we order more than last year? Do we order less than last year? And how would the outlook move forward? So this was one part, right? This is the first tool. I have a follow-on question, and I think this is a really important question. Even though the model is compromised, even though there are lots of qualifications, even though it doesn't factor the rationale or the reason that we don't have a data set adjusted for the impact of the pandemic, we don't have a data set adjusted that we've adjusted, we don't have a model that we've adjusted for seasonality. Despite fact, here's another question. Remember the probabilities, the probability that we calculated in this specific model? So if you're thinking in terms of tools, here's a follow-on question. Follow-on question is, what's the probability of a down month? And we define a down month as something which is let's see, about 30%, minus 30% or less. So sales fall by 30%, 40%, 50%, 60%, 70%, 80%, right? What's the probability of such a month? As per our model, that number is 13%. Are you guys ready for the question? This is not a trick question. What's the probability of 2 down months in a row? What do you think the answer to that question is? What's the probability of 2 down months in a row? If you have an and, 2 down months in a row is, 2 negative months. So 1 month and a second down month, right? And is multiplied, right? So it's essentially this into this. What's the probability of 3 down months in a row? Do you see where I'm heading this? Where am I taking this? 1.69 into 13%. What does this tell you? Think in terms of how we've gotten to these are probabilities that have been calculated without estimating the impact of seasonality, probability without the impact of a pandemic adjusted data set. But despite that, what we're saying, even if we adjusted for seasonality, and let's say this number was 20%, not 30%, well, it wasn't 13%, let's say this number was 20%. So 20%, same calculation again. %, same calculation again. Remember what I said, why are we asking this question? We're asking this question because we want to understand which way things are going for Maya. We want to ask this question because Maya needs to place an order, and we're using this tool not for its accuracy, but as a thought experiment, as a thinking tool. Without the analysis, could you say that, this is like, feels like death, and going to feel like death for the next 4 months or 5 months? What we're saying, what the model is saying, at least based on what we've seen historically speaking, and yes, does not factor in the possibility, the likelihood of a lockdown, but the fact still remains that people need to be fed, diapers need to be changed, soaps need to be bought, bills need to be paid. So you can sort of keep the population down for a certain time frame, but ultimately, things have to start moving again. So now what we've done is we've just identified, I want to emphasize 2 more points. We've identified that there are multiple ways. Let me zoom out. There are multiple ways for us to go out and generate scenarios for growth. One of the common problems that comes up in financial modeling, that when we go out and build models, we don't have a good sense of what's the right range. If you think in terms of growth, most of us think in terms of growth as 5, 10, 15, 20, 25, 30%. And the more conservative, especially those of us who come from an accounting background, once you start touching 30% or you start talking about 30%, we get acutely uncomfortable. And it's okay for a business or a startup to grow at very fast clip, very fast rates in the first couple of years. But by the time you sort of stabilize, things sort of gotten under control, you're comfortable with 20, 25, 30%. You don't think beyond 20, 25, 30%. Downside? Bad months? 5%, minus 5%, minus 10%, minus 15%, minus 20%. But the real range is actually a lot more diverse. In this specific case, you can see it goes from about minus 60% to about 120%. And that's just the 2015 to 2019 data set. That doesn't include the 2020 and 2021 figures. If you add those, the numbers and the graph will change. That's one. So the scenarios, the breadth, the range of your scenarios is important. So take a look at that. That's one. 2, if you go back to order history, this table here, this is the one, right? From a modeling point of view, you can make multiple adjustments. You can slice it by months if you have enough data. You can slice it by years if you have enough slices. You can do quarters and then relate those quarters to the full year. You could do Jan to May, relate that to the full year. You could also make adjustment for seasonality. So one of the questions that came up was, we haven't factored seasons into a model. How would you adjust that? All you have to do is you go back to this part, right? This is the range, and within this range, you could possibly go out and say that I'm going to not look at the analysis on a month by month basis. I'm actually going to say March to May, this is 1, Jan and Feb is 2, and then November, December is 3, and this is 4. So I have 4 specific chunks. So I'm not going to take the year and break it into 12 months. I'm going to break them into A. So I'll go from A to B to C and to D.